Hey guys, Mr. Betts here. I want to take some of the ideas that we've talked about in the last couple of topics and combine them to give us a method for finding relative extrema. So I want to start by looking at some pictures. And so in these pictures, we've got a couple of them with a relative extreme value and then a couple of them without. And I want to talk about what's going on here in terms of what we've talked about previously. So if we look at the first graph here and this point right here where we change from the green graph to the red graph, we've got a relative maximum there. If we look at this from a calculus perspective, to the left, the green part of the graph has a derivative that's positive because the graph is increasing. To the right, we have a derivative that's going to be negative because the graph is decreasing. So what happens at this point right here is the derivative actually changes from positive to negative because the graph is changing from increasing to decreasing. I do want to point out that if we were to take the derivative at this point right here, I'm going to call that C. This is going to be undefined at that point because you can see that the derivative is going to be some positive value as we approach from the left, and it looks like it's going to be zero or maybe a negative number as we approach from the right. So the derivative there is undefined. So this is going to be a critical point on that graph. If we look at the one below it here, that point right there is a relative minimum. And if we think about what's going on with the derivative, to the left, the derivative is going to be negative because that graph is decreasing. And to the right, the derivative is positive because that graph is increasing. So at this point right here, which is also a critical point, this time because the derivative is equal to zero, we get a relative minimum. So we get this relative minimum where the graph changes from decreasing to increasing, and the derivative therefore changes from negative to positive. The other two examples I have here are not relative extrema, but they are points that are going to be critical points. So in this graph right here, the top right graph, that's going to be a critical point because the derivative is equal to zero. We get a horizontal tangent line, but you may notice that the derivative is negative to the left and the derivative is negative to the right. So the derivative is not changing signs there. So even though we have a critical point there or a critical value, the derivative is negative on the left and the right. So the function itself is decreasing on both, and we don't get a relative extreme. Same thing is true here. We have another critical point there. So that's going to be a critical point because we can't take the derivative at that point. And you'll notice that the derivative is positive on the left because the function's increasing. The derivative is also positive on the right because the function's increasing. And as a result, we don't get a relative extreme. So essentially what we're going to use here is looking at the first derivative and whether the first derivative changes sign. So this gives us what's called the first derivative test. And the first derivative test essentially says that if we have a critical point or critical number and the function is continuous at that point, then a change in the derivative is going to give us a relative extreme. Specifically, if the derivative changes from positive to negative, that means the function itself changes from increasing to decreasing, and we get a relative maximum. If the derivative changes from negative to positive, the function itself is going to change from decreasing to increasing, and we get a relative minimum. All right, so the last option here is if the derivative does not change signs, then we don't get a relative extreme. So we could have critical values, critical numbers, where the derivative does not change signs, and we don't get a relative extreme. It's also important that we remember that f has to be continuous. We're also going to get critical values where the derivative does not exist. So remember, critical values have to be values for the function, but we could have discontinuities there. So if it's a discontinuity, we're not going to try to use the first derivative test. Another thing that I want to point out is we want to make sure we're clear with our language. When we're saying that f prime is positive, that's the same thing as saying f is increasing. But we want to be very careful that we don't say f prime is increasing, because that would mean something else. So make sure that we're using the correct language for the correct function or derivative that we're talking about when we're dealing with these sorts of problems.